Ladies and gentlemen, please welcome to the stage a representative from Bright Machines.
1, 2. Can everybody hear me? Okay, awesome. So my name is Sviat. I'm Chief Strategy Officer of Bright Machines. Really happy to see everybody here today at Washington, D.C. And today we're going to talk about AI infrastructure, robotics, and AI software. First of all, maybe a few words about Bright Machines. We're a 7-year-old company. We're based in San Francisco. What we do, we focus on using AI software and robotics to build what we call AI backbone or AI infrastructure. So everything that goes to the data center, from GPU to CPU servers to networking equipment. As I said, we work with different kinds of companies, from chip designers to hyperscalers, like, you think about Microsoft, Amazon, and others, contract manufacturers, that kind of examples. You can see a few examples of our investors and partners on the right, like NVIDIA, Microsoft, BlackRock, Eclipse, and Jabil. And we have headquarters in San Francisco, a little bit of a presence in Mexico, Guadalajara. What we're going to talk today is about a huge opportunity in front of the United States. According to Morgan Stanley, it is like $10 trillion to realize reshoring to the US of critical US electronics as the other products produced in this country in the next, let's say, 10 years. But if you look back around 100 years ago, maybe a little bit more, the world changed because the assembly line was invented. Like, think about conveyor, Ford, and so on and so forth. And today, we stand on the verge of another big revolution when you combine what we call physical AI. So you combine AI software and physical presence through robotics, and that way you can impact huge industries like manufacturing and solve the challenges of bringing manufacturing back to this country. Think about like the companies that already announced big investments in AI infrastructure. You can see here the Stargate project, which is like $500 billion over the next several years. You can see Amazon that promises to invest $100 billion per year, Microsoft $80, and Meta up to $65 billion. You know all the trends that are driving towards it. You know the tariffs, you know the reshoring trends since COVID, and then of course you know the trade and energy policies that are currently evolving actually in Washington, D.C. And you should build here with American companies. That's pretty obvious, right? The challenge is that it's right now 2/3 of electronics that is being manufactured in the world is being manufactured in Asia, mostly in China, because China became the global factory of the world. And like there are two biggest advantages are what we call scale and skill. So skill, there is skill enough to do that and the know-how to do that. And then scale is like how many workers you can actually involve in those factories to build electronics for you. Those two things are not easily transferable to the US, because if you think about this, we don't have that many people who are skilled enough to build electronics here, and then more than that, you don't have like the scale that you have in Asian countries. And the way to solve it, again, is robotics and software. The way you do it, I mentioned robotics and software. To train robotics and to build better software, you need computer infrastructure that we're actually building that is basically modern data centers to train the models and improve the software. And on top of it, you need different types of AI models, from machine learning and navigation to foundational models for physical AI that are just being nascent right now and being built today. The way we think about the product and building the product in Bright Machines is actually the full cycle of the product lifecycle. You start with the design. And right now, the interesting thing is like the design engineers are actually separated from manufacturing engineers. And that's why they design things that are really hard to manufacture in an automated way. What we're trying to do, we're pushing this to the lab, go into the design phase and giving recommendations of how you build products in a better way to make it easier for automation, to use robotics and software. The second thing is, of course, assembly. And as I said, if you want to assemble here in the United States, you need to leverage for assembly robotics and AI-enabled software instead of tons of human beings on the lines. The next thing would be, of course, use of the product. We don't touch that. But from the manufacturing lifecycle perspective, we touch the circular, which is when you need to take it out after, let's say, 3-4 years in the data center, and you need to take out precious parts like memory modules or CPUs for further reuse, recycle, or resell. And that is how we look at this across all the data layers that Bright Machines has access to, collects, and improves it with the continuous improvement and the full life cycle of the product. And now I'm going to give you a few glimpses, like a demos in each of the steps, how it looks like, and what we actually do in each of the buckets of the product lifecycle. The first product that we call Bright Designer, we recently launched at NVIDIA GTC conference in March this year. It runs on NVIDIA Omniverse, and that runs on Microsoft Azure instance. And this is a simulation of the assembly process and the design. And then you simulate a process and give recommendations how to improve the design of either the robotics or the product itself to make it easier to assemble. Let's hope it's going to run. Yeah, so here you can see our robotic cell, and within it you can see a design of a particular server that one of our customers sent to us. You can see heat sinks, you can see the empty spaces where you need to insert memory modules. You can see different dimensions and our robotic end of arm. Right now it's the use case of like a memory module being inserted in the server. You can see the distance measurement and clearances. And then you run this test and you can say if your heat sink is in the right place, is it enough space to insert a memory module or not. On top of it, you can also simulate a whole line in your facility. Here you can see multiple robotic cells. Each of them runs one particular process or what we call a skill. Then you put them together in the system. That's an example of how automation engineer is going to talk to a factory engineer when they design this line before they deploy it in the factory. But the idea here is that you do the simulation first, you simulate the processes, you run this server, in this case, through those parts of the process, and then you do design recommendations to either the line that sits in your factory or the product itself that you're going to build with this line. And here's an example of some data that we talked about a few moments ago. The other thing I want to demo today is what we call Smart Skills technology. Smart Skills is our secret sauce behind the way we navigate and inspect. It's AI-enabled algorithms that tell robotics what to do in this particular moment. So the way we program, we don't program, we actually teach the robot what a server is, what a CPU is, and then we just place it under the cameras, and the robot needs to decide on himself how to assemble it. So here you're going to see how we introduce new products, navigate and inspect. This is an example of a 3D point cloud for a server. That's how our robots see a new server that comes in on the line. We take a few hours to teach them, and then we run the tests. So similar to the design that you saw, this is a test of memory module insertion into the server, but it happens in real life. We're only doing a dip here because you do a lot of demos, so you're going to destroy the sockets. That's why we do only the dip. Here you can see live change of the angle, which is to 10 degrees. And then in standard automation, robot just go through this and destroy it. In this case, it changed the tilt of the angle, and it doesn't destroy, it goes to the second cell. The second part of the Smart Skills is what we call inspection. It's pre- and post-assembly inspection for debris or for classification. This is an example of classification, whether the memory modules are fully inserted or not. And then the robot is going to give the data, the computer going to give the data, green and red. Greens are fully inserted, red there's a problem or they're empty. And then the operator or the computer can decide what to do next. The other example is the heat maps based on debris. So for example, in real production, it's not a secret that sometimes people leave things when they build a server. Sometimes it's screws, sometimes it's hair. And then the inspection that we run on our cells can locate where some debris happened. So you can see the heat map with a screw, with some metal parts, with a wire. And in this case, you can improve quality and avoid some really costly mistakes. The next thing I want to show is the integration of how we use cobots. Before that, you had robotic cells. Cobot is a collaborative robot, so it's safer to work with it for human beings because it's going to stop. It has a lot of force sensors, not to create any damage for the operator. And in this case, we use a cobot to integrate NVIDIA DGX H100 GPU clusters into the server chassis before it goes to the data center rack, and then the company runs it. You need to pay attention to the fact that this thing is around 60 to 70 pounds, so it's really heavy. And on top of it, those GPUs are really expensive. So this cluster with 8 GPUs is around $250,000. So we take it out of the box, we place it really precisely in another metal box. There are several pins, so you need to be really precise and careful. And after that, we're going to do the end-of-arm tool change, take a screwdriver, and do 17 blind screw driving operations. Again, keep in mind that because it's slow, complex, and so expensive, it's really high price if you make a mistake. When you do all the screw driving operations, the GPU cluster is fully connected to the chassis, and you can go to the next process. Again, if you make a mistake and damage the board, technically you cannot fix it. The board is gone, so the whole cluster will be gone. So that's why it's so important for customers to automate that example of an operation. Because before that, if you don't automate, you have two-person teams and a crane because it's heavy, and they do it in a really slow way because, of course, they're afraid to break things. The other thing, we talked about the life cycle, right? Like the third step in the life cycle is circular, like disassembly. And here you're going to see an example of how we use our similar lines, same software, to disassemble servers and take components out before we reuse, resell, or recycle them. So first you're going to see the removal of the heatsink. Under the heatsink, you're going to see the CPU. And in this particular example, also pay attention to the fact that the design of the CPU is really complex. So there are like several clips. And for a robot, to unclip it is not that easy. Even for a human, it's not always easy. But we figured this out, and you can see how it's going to unclip it and then take CPUs out and sort them out into special cases before the company can decide whether they're going to reuse it or resell to somebody. And then the last step would be here, like when you remember we took memory modules in the server, now we're going to take them out of the server, because very often memory modules, after 3-4 years, they can still run for another 3-4 years, and the same companies that use them in the data centers, they either resell them to smaller data center companies or actually reuse in their new servers. Think about also how you run manufacturing around the world or around the country. What happens usually right now, you have multiple factories, each of them runs different software and run different operations, completely different people, as you can imagine. What we're trying to do and we're trying to achieve, we install the same equipment, the same software in different factories around the country or around the world. You can have transparency and visibility to do benchmarking and comparisons of them. And more than that, you can use Control Tower to push new products to those factories live over cloud. So instead of flying your engineers around the country and teaching people who work on different lines in different states, you can actually teach robots in one location and then use cloud to push it and launch new product production and manufacturing much faster. Here I want to show you quickly the before and after of how, sorry, I know it didn't work out. Let me try one more time. Let's give it like 5 seconds. But the idea of this video is like before and after, how it was assembled manual on the left, how it is assembled in an automated way on the right. It doesn't work, I'm sorry about that. You can check it out online if you search for Bright Machines. I hope this video is gonna work. This one works. So here is like our vision for the factory of the future. You start with the design and simulation of the design, as we talked about the lines and the product design. Then you have this robotic lines in this factory in the US, building your servers. You have operators who can check the stats, check the health of the line. Then again, you have robotics that builds the racks. Then you do the rack, burn the GPUs and testing. That's the line level assembly. And that's the vision for what we call like AI-enabled and robotics-enabled factory that you can put in any place in the world. It provides you highest quality of security, highest levels of quality, speed of introduction of new products, and you can do it in really expensive markets like the US, regardless of the dependency of human labor. Thank you. If anybody has like a few questions, I'm happy to answer a few questions. We have like a few minutes left. We can try it. Yes, there's a question.
Thank you so much. Do you think a lot of manufacturing companies will quickly adopt to this kind of movement, to adopting this?
Really good question, because when you try to disrupt the industry, it doesn't happen within a day. I think more and more companies pay attention to this movement, and because of the changing policies in this country, you have more incentives to actually go to this route. And at the end of the day, because AI moves so fast, and AI moves to physical spaces right now, there's another really important incentive to pay attention to this and actually implement such innovation. Because if you don't do it now, in 3 years or in 5 years, it might be too late. And other companies are going to do it much faster in other countries around the world, and then you're going to lose in terms of competition. If no, any other questions, thanks a lot for the time.